talk about two types of friction. The first one is static, and this is starting from no motion till the object is, we call it about to move. Now, that force of friction, we call static friction. It can be 0 or greater, okay? And this is Fs. And the maximum value that is can get is mu s times the normal. Mu s here, we call it coefficient of static friction. It doesn't have a unit, it is unitless. N, it is normal force, and that normal force, it is in newtons. Now, one thing that I want you to know here, that we don't have always normal equals mg. That is the case only when I have it on a horizontal surface like this. Then here, this is mg, this is the normal. This is the only case, but you might have other cases where the normal equals more than the weight or less than the weight. Now, if you should understand, if you will understand that there is motion in your problem, then we are talking about kinetic friction. And then here we have motion, and if k equals mu k times the normal. Now, when we talk about kinetic friction, okay, this is a mu k, coefficient of kinetic friction. And N again here, it is the normal force. And I'm gonna show you now how we are going to use these in, let's say, problems related to this chapter. Any questions so far? Okay, let me do the following. The first thing is, the first example I'm gonna do is, I have a 10 kilogram box that is being pulled horizontally across the floor with a force F applied A. Now, mu k is 0.3 and mu s is 0.4. Determine the force of friction if first Fa equals 0, Fa equals 10, Fa equals 20, and Fa equals 38, and Fa finally equals 40. Now, I will say here, okay, the Fs maximum, the maximum value for static friction, it is mu s times the normal, okay? And in this case, I need to determine what is the normal. Now the steps, as I mentioned again, these are the steps. This is the rubric that I'm gonna grade. If you're gonna have a free response in your exam, this is how it should be graded. The first step is sketch the problem. Okay, then here I have this surface. I have my box here, and the box was pulled by a force. We call it Fa to the right. We know also that we have force of friction. Okay, then this is like simply what is the sketch of the problem. The second one, it is the free body diagram of the object under the question. The question that is asking, like the question is asking about an object, and that object is my box here. Then what I will do is I will have my X. You should now, for free body diagrams, you should have your X, your Y. I know that there is the force applied here. This is gonna represent the center of the object. I have here force of friction, which like I need to determine if they're static or kinetic. Also, I have here mg, and I have the normal. Now, in order for me to determine what is really the force of friction, I'm gonna now here derive equations. Okay, for this one here, I don't need the X. I need to talk about the vertical first. Then I'm gonna say sigma Fy equals 0. And from that, I will say normal minus mg should equal 0. And from that, you're gonna get normal equals mg. For this question, I need to calculate the maximum value of friction, which is mu s times the normal. Then it's gonna be 0.4 times the weight, and the mass is 10 kilograms, and this is 9.8 meters per second square. What I can do here is I can calculate mu s to be mu s times the normal, 39.2 in newtons. Then when I have Fa equals 10, Fs is 10 in newtons. When I have Fa 20, the applied, then the force of static friction was 20 because the object did not move. When Fa also 38, okay, I'm still having Fs. Okay, because here, no motion, because these are all the values for Fs. Now, when F applied equals 40 newtons, this is greater than mu s normal, then this is the kinetic friction. And we are going to find Fk equals 0.3 newtons times the normal, 0.3 times the normal, and that is gonna be the 29.4 newtons. Any questions here? Now I'm gonna move to the second example since you don't have any questions. And that one, it is, I'm gonna add like a force that is not horizontal. Then I will have this problem for you. A 10 kilogram box is being pulled across the floor with a force that it is 40 newtons, but it is at an angle that is 30. You might have the angle below the x-axis, then it should be negative. Okay, but this one here, it is above, then it's gonna be positive. What is the acceleration of the box, assuming now mu k is 0.3. Now, the first here for the solution, the first thing I will do is my sketch. Then I'm gonna draw my box here. Okay, this is the force. This is 30 degrees. And I have force of friction. And of course, it's going to be kinetic because we are talking about acceleration. Now, I want to draw free body diagrams. And here I will say the following. My axis here. This is my X. This is my Y. I have here one of the forces, which is that force F. This is 30 degrees. I have force of friction, Fk in this direction. I have the normal. And I have also the mg, the weight. This is my free body diagram. Usually after free body diagrams, we need to derive equations. How can I derive equations? By applying Newton's laws. And it depends which law I'm talking about. Sometimes you will be working with the Newton's first law, sometimes with second, sometimes maybe second and third, sometimes second and first. It depends. For this one here, I have acceleration, and I will say this is my assumed direction for acceleration. The next step is I want to say that I want to apply first sigma fx equals ma. Then I will say f cosine 30 minus fk should equal ma. This is my first equation, but still I need another one, and that one I will get from sigma fy equals m a y. Here it is m a x. We don't have any acceleration along the y, and then this is going to be 0. I can say here normal plus f sine 30 minus mg should equal 0. This is one of the cases that I was talking to you, that the normal here, it might be less than what? Less than the weight. In these problems where I have, I will say friction, I need to calculate the normal. Then from 2, I can say normal is, okay, this is 10 kilograms, 9.8 minus the force, which is 40 in newtons, times sine 30. Sine 30 is 1/2. Then, okay, let's see the numbers. Okay, this is gonna be 98 minus 20, and that is gonna be 78. Then this is the normal. It is 78 in newtons. All right, and then here, okay, how many sig fig I have? I have 3, okay. Okay, then now here I have calculated the normal. And from the normal, I will be able to calculate Fk. Fk, it is a mu k times the normal. And then it is the 0.3 times 78. And that is going to be 23.4 newtons. Then I should go back to equation number 1 from equation 1. Okay, I have Fa cos, or like F, I call that F cosine 30 minus Fk should equals Ma. And then here I will say F is 40. And here I have cosine 30 minus 23.4. And that is the 10 times A. And from that, I should be able to get 1 point, I think it is this is the answer, 1.12. Any questions?
Yeah, I have a question. For the normal force, how did you come up with that equation? M plus F sine 30 minus the weight.
Okay, thank you. Your question is very important. Okay, now if you will, okay, have the free body diagram, look here for the F is gonna have two components. One of them Fx on the x-axis and one of them is Fy on the y-axis. That Fx, it is F cosine, the angle, and that Fy equals F sine the angle. Then on the y-axis, actually you have two forces. The normal, like the positive one, you have the normal plus Fy, normal plus F sine theta, and you have mg downward. And this is the reason why I look here, n plus F sine 30. These are both on the positive y minus the one that is on the negative y. Does this answer your question?
Yeah, thank you.
All right. Thank you for your question. All right, I will move to the third one, unless you have questions. Okay, you can hold a box against a rough wall and prevent from slipping down. By pressing hard horizontally. How much force must you apply to prevent slip? Okay, this is here. You have your textbook or a box or whatever. You're holding it against the wall and you wanna prevent it from slipping. Now the situation, okay, the sketch is, this is the wall and here is the box. And this is your hand. Okay, trying to stop it from slipping. This is the sketch. Then this is step number 1. Number 2, I need to draw free body diagrams or diagram of the box. And that is going to be, okay, this is my X, this is my Y. I have here mg. I have here force of friction, of course, is going to be upward. I have here my push. I'm going to call it P. And here I have the normal from the wall. Okay, then I have all these forces acting on the object, and my object is stationary. When it is stationary, this means no motion. And then this is the case when I am talking about Newton's first law. Then this is going to be a Newton's first law. What I can do is I can say now, okay, derive equations. And I will say sigma fx should equal 0. Then it is P minus normal equals 0, which means P equals normal. Also, I know that sigma Fy should equal 0. Then force of friction minus mg should equal 0. Now, what I can do is here is I can say that also force of friction should equals mg. Now remember, force of friction, this is a static friction, mus times the normal equals mg. And the normal, we know that it equals from equation number 1, mus normal is equal to P here. Then your push should be mg divided by mus in order to have that textbook or box stationary, not slipping downward. Then you're gonna prevent that box or textbook from slipping down by applying this force that depends on mus. Any questions? Example 4, I'm gonna work with connected objects. I'm gonna solve for you 2 problems here. One with friction, one without friction. Okay, and we're gonna see, how really we are going to deal with a situation where I have 2 objects and they are really connected by a string. And I might maybe, calculate the tension or any. I have here, okay, the first one is gonna be frictionless. And just here, I have a table that doesn't have any friction. I have a pulley here. I have a mass here. that mass, I'm gonna call it M1. Labeling here is very important. This one is 3 kilograms, and this one is 4 kilograms. Okay, sometimes you will not be able to predict, like not in this one is very easy, but sometimes you will not be able to predict in which direction the acceleration is going to be. Then you're going to assume a direction, and if it is going to be not the actual one, when you are going to get the value for your A is going to be negative, then you're going to say, oh, it should be the opposite. Okay. Now, what I will do here is I need to calculate what is required here. Calculate the acceleration. Sometimes they might say of mass 2. Or they gonna say calculate the acceleration of the system, because remember, these are two connected masses. They're gonna accelerate with the same acceleration. Here, I need to draw two free body diagrams, one for mass 1 and one for mass 2. I need derive equations for mass 1. I need to derive equations for mass 2. For mass 1, this is my x-axis. This is my y-axis. I know that every object has a weight. Then this is M1G. There is a normal one here. And there is a tension, T for tension. This is the only forces that they are acting on mass number 1. And I can also on the side put here, don't put it in the free body diagram, the acceleration vector. For the second object, which is mass 2, I have two forces acting. One of them is M2G, and the other one is the tension. There is no normal here. This is in the air, then there is no normal, but there is a rope that is, okay, trying to pull it up, down, sorry, here. It's trying to pull it up, but as a result, it will accelerate down because I will assume, not I will assume, actually the weight should be more than the tension. In this one, because I don't have friction, I don't need to calculate the normal unless they are asking you about the normal. But what I can say here is sigma fx equals max. And here I'm talking about mass 1, then T is the only force. T should equals mass 1 times A. This is the equation for mass 1. For mass 2, I don't have any forces along the X, then I'm gonna have sigma Fy equals MAY. And remember the accelerations are the same. Then this is T minus M2G should equals mass 2A. I have two equations now with two unknowns. T is not known and A is not known. Then I will say I need to find a way to substitute this value for T in this equation. Then this is here. This is 2. Substitute 1 in 2. Then you are going to get M1A minus M2G should equals M2A. And I can simply, oh, I forgot my minus here because this one is accelerating downwards, then there is a minus. Okay, then I can say M1A plus M2A should equals M2G. I can factor A here because I need to isolate A, and then M2 over M1 plus M2 times G. This is my acceleration. Then I can say it is the 4 kilograms divided by 7, because their total is 7, times 9.8. This is going to be my acceleration. It's going to be 4 divided by 7 times 9.8. And that is going to be 5.6 meters per second square. Any question?
Why is M1 plus M2 the denominator and not the numerator?
Again, please.
Why is M1 plus M2 the denominator?
Because if you look here, how are you going to solve this equation? Can you see here the equation?
Never mind, you just divide M1 plus
Yeah,
M2.
excellent,
Okay,
yes.
I didn't see that. My bad.
Both sides, excellent, very good, thank you. Okay, look at it, and if you have any questions.
Okay, I think I have another question.
Do you have another question?
Yeah, okay. Why would you substitute the first equation into the second equation?
Because here, remember, I have this one, it's not known, and this one is not known. Okay, I need to have only one variable. And this is this is the way that we solve these. I want you to review how to solve two simultaneous equations. This is one of them things from math. Okay, we like here, I have two unknowns. Okay, I will not be able to solve the equation, like T is not known and A is not known. And then I need to get rid of T, and instead of T, I put M1A, right? If you can see here.
Yeah, I see.
Yeah. Yes. Okay. All right, let me do one more. Which is the same exact one. Okay, I'm gonna get the same exact one, but now I have friction. The only thing that I'm gonna add is the I will say the friction. Then this is M1, M2, the same numbers. M1 is 3 and M2 is 4. but just I'm gonna add that the mu k is point, let's say 1.3. Okay, I'm gonna have it. And then this is really the thing that I will use it for this coming question. All right, now again, I need to draw free body diagrams. Now, the only difference that is gonna be between the two free body diagrams, I'm gonna copy them, okay? Because they're gonna be exactly the same, just what I need to do is I need to add a force, which is the force of friction. Then here I will have this here pasted for you. And what I have here is the same, everything is the same, except I'm gonna choose a new color here that I have here, FK, okay? Then it's the same exact thing. Nothing is changing except that I'm gonna have force of friction for mass 1. Now my equations for a Newton's second law, they're gonna change. Then for the vertical one, I need sigma, because now I have friction, I need to use that one. Sigma Fy equals 0, then normal 1 minus M1G should be 0, and normal 1 equals M1G. Now for the for the x-axis, sigma Fx equals MAX, then I can see now it's gonna change. T minus Fk should equals M1A. Okay, then this is one of the equations. For this one, it's gonna stay the same. Sigma Fy equals MAY, and it's gonna be T minus M2G should equal M2A with a negative here. This one, I can simplify by substituting the value for Fk. Remember, Fk always, it is mu k times the normal. Then it's gonna be minus mu k times the normal, and that is gonna be M1A. I know also that the normal can be replaced by M1G. And now I have, this is the final thing that I have. It is a little bit more complicated than this one, the previous one. Here, what I can do to get rid of T, because I have two unknowns, is to subtract. I can say 2 minus 1, then I'm gonna say T minus M2G minus T plus mu K M1G, and that is gonna be minus M2A minus M1A. Now I can eliminate my T's here. Let's bring these to this side or multiply everything by negative. M2G minus mu K M1G should equals M2A plus M1A. And then finally, I will separate or isolate A. And then my A is going to be now M2G minus MUK M1G divided by M1 plus M2. This is with friction. What I can do now is just plug in the numbers. This is 4. This is 9.8. This is point, I said, I think 3113. This one is 3. This one is 9.8. And the total for the masses is 7 kilograms. You need to calculate that. Okay, I need to calculate that, which is going to be 0.13 first, times 3 times 9.8. This number is going to give me 3.822. Is it? Yes. Okay, and then 4 times 9.8 minus 3.822. And that divided by 7 is going to give me 5.05 meters per second square. In the first one, it was 5.6. Now it's going to be less. And of course, this is because I have friction. Any questions? I'm going to post another, as I told you, another session that is going to be recorded for the last part, because I think now it's enough for you, like for how many examples I did, like 4 or 5, then like 5.